In this video, we're going to be looking at how to write the formula for the inverse of a one-to-one function. So suppose we're given the formula for a one-to-one function. Well, there's a four-step process here. Now notice if you have, say, a number, it's very easy to write the inverse of a number, the multiplicative inverse. The inverse of 2 is just 1/2. So when you multiply 2 by 1/2, you get the identity, which is 1. And there's a temptation by students, a false temptation, to do the same thing for a function, is just to take 1 over that. That is wrong. If you do that, it's going to lead you straight to an incorrect multiple choice selection, straight to it, and you can believe that will be in there. So it's a four-step procedure. If all you had to do was to do that, we wouldn't be teaching you a four-step procedure. So the first thing we do is replace f of x with y. You swap the x and the y's. Then you solve for y. That is the most difficult step. So what does it mean to solve for y? You have to rewrite y by itself on one side, preferably the left-hand side. And then what you have over here can be any combination of numbers, operators, like addition, subtraction, multiplication, division, or any combination of x's. So y by itself, not y squared or y plus y squared. It has to be y alone, and you can't have any y's on this side. Once you've done that, then basically you're through. You just replace y with f inverse. So let's go look at an example. So this is a one-to-one function. And if that's f, what is the formula for f inverse? Okay. Well, the first thing we do is replace f of x with y. So that's what I've done there. What's the next step? You swap your x's and y's. Okay, so everywhere there's a y, I'm going to write an x, and everywhere there's an x, I'm going to write a y. And then you want to solve for y. That is the difficult part. Okay, so I have to get y by itself. So if you have a fraction like this, the first thing you really should do is try and get rid of the fraction. So I'm going to multiply both sides of this by y plus 7. Okay, so when I do that, these will cancel, the y plus 7s. That was the whole reason why I did that, is to get them to cancel. And so I'll be left with 2y minus 1 over here. And then what I have to do now is to distribute the x through. Okay, now, you have to solve for y. You have to get y by itself. So what I need to do right now, some students at this point will just divide everything by x and say, okay, I'm done. No, because you've got a y over here. Get everything with y on the left-hand side. And everything that doesn't have a y, get it to the right-hand side. So subtract 7x from both sides. That should help matters along. So subtract 7x from both sides. So when I do that, those will cancel, and I'll have x times y equals that. Now, that's got a y in it. Get it over to the other side. So let's subtract 2y from both sides. So those will cancel, and I'll be left with that. Okay. What we need to do next is, let's factor out the y. And let's actually factor out the negative symbol. Since both terms are negative, if both terms aren't negative, you don't need to do that, but I think I'm going to do that. So what happens if I distribute the negative sign through, I get that. Now, the goal is to get y by itself. How do I get y by itself? What do I need to do to both sides? I need to divide both sides by x minus 2. So now, since this is y times all of that, those will cancel. And this negative sign can just come out the front. Okay, so that's a correct answer. Now there's different ways you could see it. Okay, so just like with the fraction -3/4, that's the same thing if 3 is in the numerator, the negative sign is in the numerator, or if the negative sign is in the denominator, or if you just have it out the front. Okay, so that's the same as I could apply it to everything in the numerator, or I could apply it to everything in the denominator. And would give me that. I'm just saying I would expect to see it like this on a multiple choice test. So -x + 2 is the same as that. Now once I've solved it for y, which is what I've done here, the last thing we do is replace y with f inverse of x. And that is my formula for the inverse. Okay. Now, there's another question that you could have. If f of x is equal to our same function that we just had, what is the domain of f, the range of f, the domain of f inverse, and the range of f inverse? Now, we know that the domain is what the x values are allowed to be, and the range is what the y values are allowed to be. But if you have a function and its inverse, the domain of a function is equal to the range of its inverse. You just have to make allowances for the x's and the y's. And similarly, the range of a function is equal to the domain of its inverse. So you just have to swap up the x's and the y's. Alright, so how would you go about answering this? Well, first thing you have to do is to find the formula for f inverse. And we just did that. We just did that in this example. So 1 plus 7x all over 2 minus x. Now let's answer the domain question. So what is the domain of f? The domain is what the x values are allowed to be. To be doing that, to be in this math course where we are now, you already should know how to do that. This is what the x values are allowed to be. This is a fraction. You're not allowed 0 in the bottom, so x is not allowed to be -7. So any x as long as it's not -7. Okay, now let's look at the domain of f inverse. Here's my formula for f inverse. The domain is what the x values are allowed to be. You cannot have 0 on the bottom of a fraction, so this x is not allowed to be 2. So any real number x as long as it's not 2. Now I'm going to make use of this. The range of f is equal to the domain of f inverse. You just have to adjust the x's and the y's. The range is the allowable y values. So the range of f is going to be any y value such that y is not equal to 2. What is the range of f inverse? Well, the range of f inverse is going to be the domain of f. You just have to adjust for the x and the y's. So the range is what the y values are allowed to be. And so for my range, it's going to be any y such that it's not equal to -7. Okay. And so that's how you would answer something like that. You have to use this fact here. And you have to calculate an inverse. Okay, so what I'm going to do lastly is another calculation of an inverse. What if you're asked to calculate f inverse for this? Okay. Well, some students will look at it in their calculator, put x squared minus 2. And then say, hey, wait a minute, this doesn't pass the horizontal line test. That's not a one-to-one function. Well, yes, it is, with that stipulation. So the x values are restricted to 0 or negative. So I can only have points where the x value is 0 or the x coordinates are negative. So the graph of this, with this restriction, looks like that. And it does pass the horizontal line test. Okay, so replace f of x with y. That's what I've done there. And then what's the next step? Swap the x and the y. So I've swapped the x and the y, and also there where the restriction is. Okay, then we have to solve this for y. Okay, well, how could I do that? Why don't we add 2 to both sides? Now I want to get y by itself, so I'm pretty close to that. It has to be y by itself. It can't be y squared. Let's just swap the sides. I can do that because I want the y over on this side. Right, this is coming along for the ride. All right, now how do I get y out of y squared? Well, I take square roots of both sides. When you take an even root of both sides, there are 2 possibilities. You have y equals plus or minus that. But we have this restriction. Y has to be less than or equal to 0. So, because of this restriction, I choose the negative symbol because of this restriction. So if x is -2, this is fine, because then that would give the negative of the square root of 0, which is 0, and the negative 0 is 0. Okay, so putting all of this together, I take the negative. And that's my formula. Now, once I have y by itself, then I just replace it with f inverse of x. And from what we learned from previous ones, this is what my function f looked like with the restriction. Let me clear that. And now let's take the negative square root of x plus 2. Okay, and that looks like that. Put that over here. And so that's going to be something that looks a bit like that. It should cross there at 1, 1. And so that's what the graph of this one looks like. And then it should be, we've got to make allowances for the fact that I'm drawing it freehand. These should be symmetric to each other with respect to this line. So that ends this video.